Hi there, and welcome to this video on A-Level Chemistry for the AQA Specification, focusing on the topic of amount of substance, and in particular, on the mole and the Avogadro constant. Hi, I'm Manisha from StudyMind, where we help you to revise A-Level Chemistry with our helpful revision resources tailored to your subject, your specification, and to you. If you're new here, please make sure to click that subscribe button, and whilst you're watching, please leave any comments down below about anything you're unsure of. If it's your first time watching, make sure to let us know so we can send you our free revision resources. We also have helpful timestamps to guide you through the video. So, let's get started. Welcome to lesson 2 of 5 in this tutorial, covering the mole and Avogadro's constant. This is the second in our set of 5 tutorials on the topic amount of substance. In the last video, we looked at the electron configurations of atoms and the definitions of ionization energy. Let's outline our key learning objectives for this session. First, we'll look at the mole and Avogadro constant, move on to amount of substance, and finally look at the concentration of a solution. Here are the specification points for this tutorial. Pause the video now to have a read through them before we begin. We'll start off by looking at the mole. As always, it's important to remember your definitions in this section. We've got 2 important definitions for this specification point. The first is the mole, and the second is Avogadro. The mole is simply a unit used to measure the amount of substance. It's often written as MOL in the shorthand form. Let's move on to our next spec point, covering the Avogadro constant. The Avogadro's constant is simply a number. It is equal to 6.02 times 10 to the 23 atoms. It is also the number of particles found in 1 mole. These can be atoms, molecules, ions, or electrons. Let's fill in this table to cover some core concepts. We'll start off by looking at atoms. Let's look at 1 mole of hydrogen atoms. We know that 1 mole will be 6.02 times 10 to the 23 atoms. Now, let's look at molecules. We know that 1 mole of water molecules will be 6.02 times 10 to the 23 molecules. Now let's look at potassium ions. We know that 1 mole of potassium ions will be 6.02 times 10 to the 23 ions. Finally, let's look at electrons. 1 mole of electrons is going to be equivalent to 6.02 times 10 to the 23 electrons.
Particles of a substance that can be measured can be either electrons, atoms, molecules, or ions. When calculating the number of particles of a substance, you need to alter what you write after the Avogadro's constant. For example, if you are dealing with molecules, Avogadro's constant will be followed by the word molecules instead of atoms. It's helpful to learn the following equation as it helps to adjust your calculation depending on which pieces of information you're given. The equation is the number of particles equals the number of moles times the Avogadro's constant. Let's have a go at this exam question. Pause the video now and see if you can attempt it. The answer to this question is 2.05 times 10 to the 3 sodium atoms. Let's work through it together step by step to see how we reach this. Firstly, we must write down the formula. We've just seen this formula earlier. This will be the number of particles is equal to the number of moles times Avogadro's constant. Now, we need to write down the quantities required in the equation. So the particle that we'd be dealing with is a sodium atom. We know that the number of moles is 0.34. We also know the value for the Avogadro's constant. This is 6.02 times 10 to the 23. Finally, we need to substitute the quantities into the equation to get our answer. So in this case, we would be doing 0.34 as the number of moles times Avogadro's constant, which is 6.02 times 10 to the 23, and this would give us a value of 2.05 times 10 to the 23 sodium atoms. Don't worry, you don't need to memorise the value of Avogadro's constant. It will always be given to you in AQA exam questions. However, it's a good idea to remember roughly what it will be, since this can save you some time in the exam. We've now covered the first two specification points for this section. Let's look at the final one, which covers some calculations. We'll start off by looking at mass and its relationship to relative molecular mass, or MR, which we met in the previous video. The mass of 1 mole of a substance is the same as the relative molecular mass of the substance in grams. For example, the relative molecular mass of carbon dioxide is going to be 44. This means that 1 mole of carbon dioxide will have a mass of 44 grams. When you have an equation that you need to remember, it's useful to draw yourself a formula triangle to help you visualise the calculation you need to do. To calculate the number of moles, you can use the following equation. The number of moles is equal to the mass of the substance over mR. Here is a formula triangle which will help you to visualise this equation. Cover up the piece of information you're not given in the question to help you rearrange the equation. Now let's put this equation into practice by doing this exam question. Pause the video now to have a go at it yourself before we go through it step by step. The answer to this question is 88 grams. Let's see how we got there. Firstly, we need to write out our formula. In this instance, it would be moles equals mass over mR. Now we will write out the quantities required in the equation. So in this equation, we're not sure what the mass is, so we'll put a question mark. We know that the number of moles is going to be 2, since this is given here. And we know that the mR we can calculate, which is going to be 12 plus 16 times 2, which would give us an answer of 44. Finally, we will rearrange the formula to find the mass and substitute in our quantities. So in this instance, it would be 2 times 44 to give us 88 grams. This leaves us with our final answer of 88 grams. Now let's look at concentration. The concentration of a particular solution is the number of moles that are dissolved in 1 decimeter cubed of the solution. 1 decimeter cubed is equal to 1 litre. The unit moles per decimeter cubed is a unit used to measure the concentration of a solution. The concentration is effectively the number of moles per unit volume. This is the equation we use to calculate the number of moles when dealing with concentrations in volumes. Again, we can put this into a formula triangle, with moles at the top and concentration and volume at the bottom. You need to be careful with this equation, as the units of volume may be either in centimetre cubed or decimetre cubed. To convert between centimetres and decimetres cubed, you should divide the volume by 1000, as 1 centimetre cubed is 0.001 decimetres cubed. Let's have a go at this equation now. Pause the video to have a go at it yourself before we go through it. The answer is 3.75 grams. Let's go through it step by step. Firstly, we need to calculate the mR. We can do this using our formulas. So the mR in this case would be 40 plus 12 plus 16 times 3. This gives a value of 100. Now, we need to calculate the quantities required. So in this case, we've been given our volume in centimetres cubed. This is 25. However, we've already discussed that you should always convert centimetres cubed into decimetres cubed. So to do this, we want to find the volume in decimetres cubed. So this would be 25 divided by 1000. This gives us a value of 0.025 decimetres cubed. Now we want to find the number of moles. So we have our concentration, which is 1.5 moles per decimetres cubed. And we have our volume, which is 0.025 decimetres cubed. This gives us a final answer of 0.0375 moles. Now we need to use the formula to find the mass. So we would do mass is equal to the MR times the number of moles. So in our case, this is 100 times 0.0375. This gives us 3.75 grams. We've now covered all the specification points for this section. Feel free to skip back through the video if you're unsure about any of the topics we have covered. We have now completed Lesson 2.
If you liked this video, make sure to catch our latest videos by subscribing down below and leaving a comment on a topic that you'd like to see a video on. Click here to watch more videos on our series of A-Level Chemistry, or visit our website studymind.co.uk for past paper compilations by topic and specification.